first part of previous year question paper with the detailed solution of ISRO Space Application Center Technician-B Electronics. The exam held on 2018. This is question booklet series A. Consider the first question. Decimal equivalent of 120 is equivalent to binary equivalent of answer is option A 1111000. This is how we get like dividing the decimal number with the binary radix, which is 2. 120 divided by 2, we get answer 60 and remainder 0. Again divide 60 with 2, we get answer 30 and remainder 0. Divide 30 with 2, we get answer 15 and remainder 0. Dividing 15 with 2, we get answer 7 and remainder of 1. Dividing 7 with radix 2, we get answer is 3 and remainder 1. Again dividing 3 with radix 2, we get remainder 1. The answer is 1111100, taking from the down to up. Question number 2. Square waveform can be seen on answer C oscilloscope. An oscilloscope is a type of electronic test instrument that is graphically displays varying voltages of one or more signals as a function of time. The main purpose is capture information on electrical signals for debugging, analysis or characterization. The displayed waveform can then be analyzed for properties such as amplitude, frequency, rise time, time interval, distortion and others. Originally, calculation of these values required manually measuring the waveform. Modern digital instruments may calculate and display these properties directly. Oscilloscopes are used in the sciences, engineering, biomedical, automotive and the telecommunication industry. This is the picture of CRO. General purpose instruments are used for maintenance of electronic equipment and laboratory work. Special purpose oscilloscopes may be used to analyze an automotive ignition system or to display the waveform of the heartbeat as an electrocardiogram, for instance. Voltage source that converts chemical energy to electrical energy is called answer B battery. A battery is a device that stores chemical energy and converts it to electrical energy. The chemical reactions in a battery involve the flow of electrons from one material, that is electrode, to another through an external circuit. The flow of electrons provide an electric current that can be used to do work. Note: motor, which convert electrical energy to mechanical energy. It works on Fleming's left-hand rule. Generator converts mechanical energy into electrical energy. It works on Fleming's right-hand rule. Dynamo convert mechanical energy to electrical energy. Question number 4. A voltmeter is used in parallel with the circuit is the answer. A voltmeter is an instrument which is used to measure the voltage across two terminals in a circuit. Voltmeter ideally has infinite resistance. Connecting voltmeter with infinite resistance in parallel ensures no current flows through the voltmeter and the voltage drop IR remains the same. This is how it connects in the circuit. Note: ammeter. An ammeter is an instrument which is used to measure the current flowing through the circuit. It has low resistance, ideally 0. The connecting ammeter in series allows all the circuit current to pass through it and hence measure it. Hence, ammeter should be connected in series and voltmeter in parallel. Question number 5. Vertical deflection coil produce the vertical motion in TV sets. The structure which has a combination of two sets of coils for this purpose is called a deflection yoke. Answer. A deflection yoke is a kind of magnetic lens used in cathode ray tube to scan the electron beam both vertically and horizontally over the whole screen. In a CRT television, the electron beam is moved in a raster scan on the screen by adjusting the strength of the beam current. The brightness of the light produced by the phosphor on the screen can be varied. The cathode ray tube allowed the development of all electronic television. Electromagnetic deflection yokes are also used in certain radar displays. A similar action in the vertical deflection coil produces the vertical scanning motion. The two sets of deflection coils are combined in a structure known as the deflection yoke, which surrounds the neck of the picture tube at the junction of the neck with the funnel section. This is the diagram of vertical yoke. Ratio of output SNR to input SNR is called, answer is option C, figure of merit. SNR is the signal to noise ratio. It compares the level of the desired signal to the level of background noise. It can be shown as the ratio between the power of the signal and the power of noise. The aim is always to have higher signal to noise ratio in a system. In other words, if it decreases, a noise in our system has less power and our SNR will be higher. We can show SNR with dB in the log domain as well. In a block A, SNR in is the input signal to noise ratio and SNR out is the signal to noise ratio output. Therefore, SNR dB equal to 10 log 10 power of signal divided by power of noise. A figure of merit is a performance metric that characterizes the performance of a device, system or method relative to its alternatives. The ratio of output SNR and input SNR can be termed as figure of merit. It is denoted by F. It describes the performance of a device. Which part of an atom has no electrical charge? Answer is option B, neutron. There are 3 subatomic particles, protons, neutrons and electrons. 2 of the subatomic particles have electrical charges. Protons have positive charges while electrons have negative charges. Neutrons on the other hand don't have a charge. Neutron. The neutron is a subatomic particle, symbol N or N degree, with no net electric charge and a mass slightly larger than that of a proton. Protons and neutrons constitute the nuclei of atoms. Proton. A proton is a subatomic particle, symbol P or P degree, with a positive electric charge of plus 1 electron elementary charge and a mass slightly less than that of a neutron. Electron. An electron is a negatively charged subatomic particle. It can be either free or bound to the nucleus of an atom. Electrons in an atom exist in spherical shell of various radii representing energy levels. Alpha particle. Alpha particles consist of 2 protons and 2 electrons bound together into a particle identical to a helium-4 nucleus. They are generally produced in the process of alpha decay but may also be produced in other ways. Question number 8. In synchronous counter, all the flip-flops change the state in, answer is option B, sequence. In synchronous counters, the flip-flops change simultaneously, and in asynchronous counters, the propagation delay of the flip-flops add up to produce the overall delay. Although synchronous counters usually have more combinational logic, the propagation delay through these gate is small compared to the propagation delay through many stages of flip-flops. So the synchronous counter will provide the least delay compared to asynchronous counter. The difference between synchronous and asynchronous counters. In synchronous counter, we use a universal clock that is common to all flip-flops throughout the circuit. In asynchronous counter, main clock is only applied to the first flip-flop, and then for rest of the flip-flops, the output of the previous flip-flop is taken as a clock. Synchronous counter is faster in operation as compared to asynchronous counter. Asynchronous counter is not fast compared to synchronous counter in operation. There is a typing mistake. Synchronous counter does not produce any decoding errors. Asynchronous counters produce any decoding errors. Synchronous counter is also called parallel counter. Asynchronous counter is also called serial counter. Synchronous counter designing as well as implementation are complex due to increasing the number of states. Asynchronous counter designing as well as implementation is very easy. Synchronous counter will operate in any desired count sequence. Asynchronous counter will operate only in fixed count sequence, up or down. Synchronous counter examples: ring counter, Johnson counter. The example of asynchronous counter is ripple up counter and ripple down counter, etc. In synchronous counter, propagation delay is less. In asynchronous counter, there is high propagation delay. The symbol Xc represents, answer is option C, capacitive reactance. Capacitive reactance is the measure of the opposition to alternating current by the capacitor is called capacitive reactance. The unit of capacitive reactance is ohm-like resistance. The symbol of capacitive reactance is Xc. Xc equal to 1 by 2 pi Fc, where F is the frequency and C is the capacitance value. Capacitive reactance decreases with increasing frequency. Conductance. Conductance is the measure of how DC it is for electrical current to flow through something. Conductance is symbolized by the letter G. Conductance is the inverse of resistance. G equal to 1 by R. Conductance is measured in the unit of Siemens or mho. Inductive reactance. Inductive reactance is the opposition offered by the inductor in an AC circuit to the flow of AC current. It is represented by XL and measured in ohms. XL equal to 2 pi FL, where F is the frequency and L is the inductance value. Inductive reactance is mostly low for lower frequency and high for higher frequencies. It is, however, negligible for steady DC current. Resistance. Resistance is a measure of the opposition to current flow in an electrical circuit. Resistance is measured in ohms, symbolized by ohm. R equal to VI, where V is the voltage and I is current. What is the temperature sensing limit of J-type thermocouple? Answer is option D, minus 210 to 760 degrees Celsius. The type J is a popular thermocouple that is commonly used to monitor temperature of inert materials and in vacuum applications. This thermocouple is susceptible to oxidization, so it is not recommended for damp conditions or low temperature monitoring. It is used for precision temperature measurements where minimal displacement and a fast response is required. For industrial applications such as furnace, kilns, ovens, boilers, flues, etc. Many types of sheath material are available. Due to the Curie point of the iron at 770 degrees Celsius, type J has a limited temperature of minus 40 degree to 750 degrees Celsius. Out of our 4 options, option D is included in this range. It should not be used at high temperature in an oxidizing atmosphere as iron undergoes a molecular change and permanently loses its standard voltage output versus temperature. 11th question. Class B push-pull amplifier. The efficiency can reach up to, answer is option B, 78.5%. Class B push-pull amplifier employs 2 identical transistors with the input signals applied to 2 stages that are 180 degrees apart from each other. The transistor to be operated in Class B mode is kept at the cutoff bias and current in the state will be equal to 0. The maximum efficiency of Class B push-pull amplifier is 78.5%. Amplifier efficiency and its conduction angle. Class A amplifier efficiency is 25% to 50%. Conduction angle is 360 degree. Class AB amplifier efficiency is below 78.5%. Conduction angle is between 180 degree to 360 degree depending upon the operating point. Class B push-pull amplifier efficiency is 78.5%. Conduction angle is 180 degree. Class C amplifier efficiency between 78.5% and 100%. Conduction angle is less than 180 degree. For a purely resistive AC circuit, the power factor is, answer is option D, unity. In a series RLC circuit, the impedance Z equal to root of R square plus XL minus XC whole square. At a resonance, the magnitude of the inductive reactance is equal to capacity reactance. At this condition, Z equal to R. Hence, at resonance, the impedance is purely resistive. The power factor is unity and the impedance is minimum. As impedance is minimum, the current is maximum. The rate of change of electrical charge is called, answer is option C, current. An electric current is the rate of flow of electric charges and it is measured in amperes. If a charge Q flows through the cross section of a conductor in time t, the current I equal to Q by T. The SI unit of charge is coulomb and measurement of electric current happens in the unit of coulomb per second, which is ampere. Arc. An electric arc or arc discharges is an electric breakdown of a gas that produces a prolonged electrical discharge. The current through a normally non-conductive medium such as air produces a plasma which may produce visible light. An arc discharge is initiated either by thermionic emission or by field emission. Voltage. Voltage is the pressure from an electric circuit's power source that pushes charged electrons or current through a conducting loop, enabling them to do work such as illuminating a light. It is measured in volts. Voltage equal to current into resistance. Flash. The flash is a device that emits light momentarily. You can use the flashlight to compensate for the lack of brightness when shooting in dimly light situations like indoors or night scenes. Thanks to the instant exposure, using the flash can also be effective to prevent camera shake and subject blur. Question number 14. Tesla is equal to option D 10,000 Gauss. The international system unit of field intensity for magnetic field is Tesla T. 1 Tesla is defined as the field intensity generating 1 Newton of force per ampere of current per meter of conductor. A Tesla is equal to a Newton per meter and ampere. In a series RLC circuit at low frequency, the circuit is option C capacitive. This is the resonance curve of series RLC circuit. From here we can identify that at below resonance frequency XL is low and XC is high. The circuit behaves like a capacitive circuit, that is leading power factor. At a resonant frequency, XL and XC are equal. Circuit behaves like a purely resistive circuit, that is unity power factor. At above resonant frequency, XL is high and XC is low. Circuit behaves like an inductive circuit, that is lagging power factor. Question number 16. Maximum efficiency of a half-wave rectifier is option C 40.6%. The maximum efficiency of a half-wave rectifier is about 40.5% and the maximum efficiency of a full-wave rectifier is twice, that is 81.2%. Question number 17. A transformer has a turns ratio of 2:1. What is the peak secondary voltage if 115 Vrms is applied to the primary winding? Answer is option B 81.3 volt. Given number of turns in primary coil N1 is 2, number of turns in secondary coil N2 equal to 2:1. RMS primary voltage equal to 115 volt. Therefore, peak primary voltage V1 equal to Vrms root 2, which is equal to 115 into root 2 volt. Turns ratio N of a transformer is N equal to I1 by I2 equal to V2 by V1 equal to N2 by N1, where N1 is the number of turns across primary, N2 is the number of turns across secondary, V1 is the primary voltage, V2 is the secondary voltage, I1 is the primary current and I2 is the secondary current. Therefore, the peak secondary voltage V2 is we can get from V2 by V1 equal to N2 by N1. Substituting the values of V2, V1, N2 and N1, we get V2 equal to 81.3 volt. 18th question. Color code for 85 kilo ohm 5% tolerance resistor is, answer is option C gray, green, orange, gold. Given 85 kilo ohm 5% means 85,000 ohm. Therefore, the color code of 8 is gray, color code of 5 is green, the color code of multiplier 1000 is orange. Tolerance 5% means gold. This is a resistor color code. This is 4 band. First and second band represent the first 2 digit and third band represents the decimal multiplier. And the fourth one is the tolerance. For black, first band is 0, second band is 0 and third band decimal multiplier is 1. For brown, it is 1, 1, decimal multiplier is 10. For red, it is first and second band is 2 and the decimal multiplier is 100. Likewise, all the colors. There is another easy code, that is B.B. Roy, Great Britain had a very good wife. You can remember that word. For gold, the tolerance is plus or minus 5%. For silver, the tolerance is plus or minus 10%. No color means plus or minus 20%. Question number 19. The ripple factor of a bridge rectifier is 0.48. The ripple factor is defined as a ratio of ripple voltage to pure DC voltage. Rectifier and ripple factor. For half wave rectifier, ripple factor is 1.21. For full wave center and bridge rectifier, ripple factor is 0.48. 20. If a small value of capacitance is connected in parallel with a large value, the combined capacitance will be, answer is option B, higher. Let C1 be the lower value capacitance and C2 be the higher value capacitance. If C1 and C2 are connected in parallel, then net capacitance CP equal to C1 plus C2. Therefore, net capacitance CP is greater than C2. A capacitor is an electrical component with 2 terminals used to store charge in the form of an electrostatic field. Capacitance is the ability of a capacitor to store charge in it. The capacitance C equal to Q by V, where Q is the charge and V is the voltage across them. Equivalent capacitance of capacitors connected in series. When n capacitors C1, C2, C3 up to Cn are connected in series, the net capacitance Cs is given by 1 by Cs equal to 1 by C1 plus 1 by C2 plus 1 by C3 up to 1 by Cn connected in parallel. When n capacitors C1, C2, C3 up to Cn are connected in parallel, the net capacitance Cp is given as Cp equal to C1 plus C2 plus C3 up to Cn. The main energy loss in an optical fiber consists of, answer is option D, all the above, that is material loss, loss due to light scattering, bend loss. What is absorption loss? These losses occur due to the impurities present in the core material. If the light ray strikes an impurity atom, the energy is absorbed by the impurity atom and charge carriers will move from one energy level to another energy level. Later this energy is dissipated in the form of heat. Scattering losses. These losses also occur due to the impurities present in the core material. Assume that a light ray strikes an impurity atom. If the energy is not sufficient to move the charge carriers from one level to another level, the light is scattered in different directions. The scattering light will propagate if the angle of incidence is greater than the critical angle. Theta I is greater than theta C. What is bending losses? If a fiber optic cable is bent, the refractive index changes and the critical angle also changes. If the angle of incidence is less than the critical angle and light ray will not be propagated. Then what is coupling losses? These losses occur if the two fiber cables are joined. The total amount of the light which is propagating in the first fiber cable will not be transferred to the second fiber. The temporary joint is called splice and the permanent joint is called connector. 22nd question. The diode with variable capacitance is called, answer is option B, varactor diode. Varactor diode refers to the variable capacitor diode, which means the capacitance of the diode varies linearly with the applied voltage when it is reverse biased. This is the symbol of a varactor diode. The junction capacitance across a reverse bias PN junction is C equal to A epsilon divided by W, where A is the area of cross section and W is the depletion region width. Epsilon is the permittivity. As the reverse bias voltage increases, the depletion region width increases, resulting in the decrease in the junction capacitance. Application of varactor diode. It is used in tuned circuits, FM modulators, automatic frequency gain control circuits, adjustable bandpass filters, parametric amplifiers. What is tunnel diode? A tunnel diode is a semiconductor diode that exhibits negative resistance, meaning the current decreases with an increase in voltage. By making use of quantum mechanical effects, the tunnel diode is capable of fast operation and can function well into the microwave radio frequency band. A tunnel diode is a heavily doped PN junction diode in which the electric current decreases as the voltage increases. In tunnel diode, the electric current is caused by tunneling. The tunnel diode is used as a very fast switching device in computers. It is also used in high frequency oscillators and amplifiers. Tunnel diode is used in different oscillators like relaxation, microwave, etc. Applications of tunnel diode. It is used like a logic memory storage device. It is used as a switching device with very high speed and used as a microwave oscillator with a high frequency. Used as an oscillator, amplifier and switcher. This is a symbol of tunnel diode. Remember the symbols. Triac. A triac is a bidirectional thyristor with a 3 terminal. That is, it can conduct in both directions. Its 2 terminals are usually designated as MT1 anode 1, MT2 anode 2 and the gate by G as in a thyristor. This is a symbol and characteristics of triac. When in operation, a triac is equivalent to 2 SCRs connected in anti-parallel. As a triac can conduct in both directions, the terms anode and cathode are not applicable to triac. It is used extensively for the control of power in AC circuits. What is die-cap? The die-cap is a conventional parallel plate capacitors with a metallization to the edge. High performance and high frequency single layer capacitors for RF, microwave and millimeter wave applications. Benefits: gold metallization for wire bonding, rugged construction, thin film technology, tighter capacitance tolerance available, easily customized. The last question of this video is 23rd one. Since input resistance of an ideal op-amp is infinite, answer is its input current is 0. Input current in an op-amp I equal to V by Z. Since input impedance of an ideal op-amp is infinite, Z equal to infinity. That if we substitute this Z equal to infinity in the equation of I, we get I is 0. The characteristics of ideal op-amp: infinite open loop gain, infinite input impedance Rin, and so the zero input current, zero input offset voltage, infinite output voltage range, infinite bandwidth, infinite slew rate, zero output impedance Rout, and so infinite output current range, zero noise, infinite common mode rejection ratio, and infinite power supply rejection ratio. Thank you.